Hello friends, welcome to my channel, and this video deals about another problem on heat balance sheet. The question is a 6-cylinder 4-stroke diesel engine of 34 centimeters bore and 38 centimeters stroke gave the following results during testing. BP is equal to 142 kilowatt and N is equal to 350 rpm, PM is equal to 3.4 3.7 bar, MF is equal to 44 kilo 44 kg per hour, CVF, that is calorific value of fuel, that is 44,800 kilojoule per kg, MA is 38 kg per minute, MW is mass of water, that is 60 kg per minute, and cooling water temperature rise is equal to 41 degrees Celsius. Piston cooling oil 35 kg per minute. Cp of oil 2.1 kilojoule per kg Kelvin. Rise in cooling oil temperature 28 degrees Celsius. Exhaust gas temperature 190 degrees Celsius. Ambient temperature 20 degrees Celsius. Fuel contains 14% of hydrogen by mass and CpG, that is equal to 1.05 kilojoule per kg Kelvin. Partial pressure of a water vapor carried in exhaust gases, that is equal to 0.06 bar. Draw the heat balance sheet on minute basis and percentage basis. Find the specific fuel consumption at full load, assuming mechanical efficiency as 0.6. Now solution. Indicated power of the engine, that is equal to IP is equal to PIM, that is indicated PMLAN into X by N, that is equal to 3.7 into 100 into 0.38 into pi by 4 into 0.34 square into 350 by 60, that into 6 by 2 to 23.4 kilowatt. Now heat supplied. That is equal to MF into CVF, that is equal to 44 by 60 into 44 800, that will be equal to 32.853.33 kilojoule per minute. Here mf will be in kg per minute, and cvf will be in kilojoule per kg. Now heat equivalent to Bp. Bp is equal to 142 into 60 Bp is equal to 8520 kilojoule per minute. Then heat lost to cooling water, QW is equal to MW into CPW into delta T, that is equal to 60 into 4.186 into 41. That will be equal to 10.297.56 kilojoule per minute. Then heat lost cooling oil, and that is QO is equal to M into Cp into delta T of oil, that is 35 into 2.1 into 28, that is equal to 20 point, that is 22,058 kilojoule per minute. Heat loss to dry exhaust gases. mass of exhaust gases, that will be equal to m into m is equal to ma plus mf, that is 38 plus 44 by 60, that is equal to 38.73 kg per minute. Then mass of water vapor formed, that is equal to m H2O, that is equal to mf into 9 into H2, that is hydrogen, that is 44 by 60 into 9 into 0.14, that will be 0.924 kg per minute. This is 4. Then mass of dry exhaust gases, that is Qg is equal to m minus mH2O, that is equal to 38.73 minus 0.924, 37.806 kg per minute. It is 30, yes. And heat lost, exhaust gases, Qg is equal to mg into Cpg into Tge minus Ta, that is 37.806 into 1.005 into 190 minus 20, 6459.16 kilojoule per minute. This will be Qg. then heat carried away by water vapor here. By using steam table we can get the value of at h at 0.06 bar and 190 degrees Celsius will be h is equal to 2860 kilojoule per kg. Then heat carried away by water vapor QWV, that is equal to 0.924 into 2860, that is H value. It will be equal to 2642.64 kilojoule per minute. And now we have to draw heat balance sheet. This is heat input kilojoule per minute, that is percentage heat output kilojoule per minute, and this is percentage. It is heat supplied that is 33,853.33. This is 100%. Here heat equivalent to BP heat to cooling water, heat to cooling oil, heat to dry exhaust gas, heat to water vapor, then F is unaccounted heat loss. That is 8520.00, and 10297.56, 2058.00, 6459.16, 2642.64, 3876.21, 25.17 in percentage. This is 30.42, 6.08, 19.08, 7.81, 11.44, this will be equal to total 33,853.33, that is 100%. Here also 33,853.33, this is also 100%. Now indicated thermal efficiency. Eta I is equal to IP by MF into CVF, that is equal to 223.4 into 60. It is divided by 33,853.33. That will be equal to 0.396, that is 39.6%. Then mechanical efficiency and thermal efficiency are taken same at full load. It is BP at full load two into 142, that is 284 kilowatt. At a half load condition, FP is equal to IP minus BP 223.4, that is minus 142, 81.4 kilowatt. This is FP. At full load conditions, FP is equal to IP minus therefore IP is equal to BP plus FP, that is equal to 284 plus 81.4, that is equal to 365.4 kilowatt. Now heat supplied will be IP by eta I 365.4 into 60 divided by 0.3396, that is 55 363.64 kilojoule per minute. Now specific fuel consumption at full load. BSFC is equal to mass of fuel by BP, that is equal to 363.64 divided by 44,800 into 60 by 284, that will be equal to 0.261 kg per kilowatt hour. Thank you for watching. Please like, share and subscribe my channel.